Hello, my name is Dalia, and in this video I'll be presenting my parametric recreation of Noor Mosque using Grasshopper as a part of parametric modeling and design and architecture course. So, the Noor Mosque, known also as Mosque of Light, is a proposal for a competition by Noods, a Mumbai-based architecture firm known for its creative and sustainable designs. The mosque was designed for a site in Dubai and uses simple geometry and natural light to create a calm and inspiring space for praying. Its circular form represents unity, and the flat, perforated roof allows sunlight to filter through in a beautiful and controlled way. So yeah, now from here we can see how the building features a flat roof line with the repeating semicircular shapes around the building, which also shown here that demonstrates the flow of the light in the building. And then we here have the same semicircle shapes that some of them has column supports, and then some of them appears to be floating. And then the building is surrounded by windows, which gives the interior an open connection to the outside. And in the top view we can see the arrangement of the roof openings that bring light into the central space. And then lastly the sections that demonstrates the idea of work vertically, and the layering of the perforated structure also demonstrates again how the light travels through the openings and spread into the prayer space below. You can understand the base of the building, which is all about the grid, and then in each cell of the grid will be placed the semicircular shapes, and then we have the mesh, which we'll be talking about later on. So the building is all about one module that will be repeated to create the building, and the first thing we have phase 1 is the main curves. So the main curves are divided into two things: the lower set curve, and then we have the arches, and then it got mirrors to the top part, and then we have the columns that will be added later on to create the building. So first of all, we have the definition revolves around one single shape, which is the rectangle with the radius, which is all controlled with this slider that will control the whole definition. First thing we have the grid, and then we take the area of each cell to place the rectangles, and then trim them to create the first module set, and then move it to the desired height, and then we use the same points and place the same rectangle shape to cut it into a quarter, and then orient it to the endpoints of the previous module set, and then we have the same shape also with the other points of the grid to create the arches, and then we have the full main curves. Now the second phase, which is all about the module connection. Here we have the module, and then each center of each shape will be connected to one another to create the intersection point that will be used later on to create the connection shape. As mentioned previously, these are the lines, and then we have these lines. We will get the intersection point, place over the same lines multi-pipe to extract the connection, which is in here, and then scale it up so it could fit more to the real building size. So now we have the third phase, which is the mesh construction. Each quarter of each shape will be connected to one of the curves of the connection to create this kind of pipe that allows the light to enter and goes all over the building. Now combining each main curve with the connection to create a surface, then a mesh, we have created the shape, and then by using kangaroo we give it a tension. So here we have the tensioned mesh. Phase 4 is about creating the pattern and morphing it into the mesh. So first of all, we need to create different sizes of circles, divide it and weave it together to create the pattern, and then these are different patterns from the same definition, and then this is the mesh pattern morph. Now by taking the mesh and converting it into surface, and then culling the inner part to divide it into two parts, one will be the surface edges, and then the other part, which is the cult, we will morph to it the pattern to create the one mesh module that will be rotated and mirrored to create the full module, which you can see in here. Moving on to the exterior part, which is by using these arches and then arraying them, taking the midpoint of each curve and evaluating whether it's in the VRAP or not, and then by doing so we extracted the edges and then sweep them to get the arches, and then doing the same thing for the module set, arraying it and then taking the open curves, sweeping them by using orient and perpendicular frame. Using the same open curve endpoints, we can make the columns, which by that will be done by the exterior part. Moving next to the interior part, which is by using the same arrayed curve, we sweep it, and then doing the column by taking this shape and then moving it and scaling it by the use of graph mapper, lofting it to create the column, and then orient it to different circle to create the exterior and interior part. Now moving on to the roof, which consists of two layers. The first layer really similar to the previous one, arraying the curve, and then instead of keeping the edges open, we close it this time, and then by doing so we use the same thing, sweep with perpendicular frame and orient to sweep the first layer of the roof, and then the second part, which is the top part, arraying it the same curve but bigger in scale. By doing so, we offset it to create the holes that will allow the light to enter, and then creating the boundary surface and extruding it to get the roof by taking the sweep shape and putting a bounding rectangle to the curves to fit it inside, and then projecting it to the floor, this will be the base curve of the window, which will be used to divide and then create the mullions of the window. After that, we loft to create the glass of the window, and then the other parts of the window to create this. Now, by combining all the elements, this is the original building of Noor's Mosque. And then when you further zoom in, you will see the morphed pattern. And now, as I mentioned before, this slider controls the whole definition. So by moving it to -2, we get different type of like curve. We have sharp edges, and then this is the semicircle as before. And I did this by making this, evaluating it to if then, and then by creating this the same mesh, we have curved edges and sharp edges, and then by doing it with kangaroo, we have the tension. And by doing the same process, we make the pattern mesh and then mirroring it to take this, we can see that we have also in here different shapes. So at the bottom, we have a circle, and then at the top, we have a rectangle, and then when arraying, the opposite will happen. So different shapes will happen. To see it more clearly, we can see how the exterior also changed, and then the interior also, as well as the roof. And now, as an extra step, I wanted to create from the roof, like inflate the semicircular shapes, and by using kangaroo, we can see how they inflate, and then combining it with the rest of the roof, you can see how it did this kind of stuff.